Hi everyone. So today we're going to work on computing what is called measures of position in reference to transactions of automobiles. So what we want to look at is just some data, because when you're looking at buying a car, you're going to look at data and you're going to look at miles per gallon, you're going to look at how long the engine has been in the car, how old the car is, and you're going to put all this data together. All right, so let's define some terms here. So data in general, remember, is just a set of numbers that we're going to use to make some information or make decisions upon. So we've already previously looked at measures of central tendencies. Those, remember, are mean, median, and mode, and they represent what a typical data set value would look like. So what we're going to do is these are called measures of position, and it's where the data set member is in reference to everybody else. So we're going to look at quartiles. And these are three values represented and divided by the distribution into four subsets, each containing 25% of the data. I don't know why there's a big black thing there. Okay, and then lower quartile is called Q1, and that's the first quartile, and it's 25% of the data is below that. Then you have your upper quartile, which is usually referred to as Q3, and that's 75% of the data is below that number. So think of it as that number and below contains a percentage of the data. Now your interquartile range is the difference between the upper and lower quartiles, and that's going to contain 50% of your data. So within this middle section of your data. Now sometimes we have outliers. Outliers are guys that are extreme. Okay, so if everybody's getting like 25 miles to the gallon and you have somebody out here getting 40 miles to the gallon, he's probably an outlier, and we would want to look at him and figure out why is he getting so better miles per gallon. And you can display your data in what is called a stem leaf plot, and it displays all the members of the data set in the notation, and it's kind of a space saver. The things that are great about it, you can see the data set members, and you can put it together and look at that data real quick, and you get a good idea of where most of the data is located. It does have to have a legend though. You have to have a key to understand what the data represents. Another plot is called a box plot or box whiskers, and shows the quartile and the minimum and maximum numbers. And it's always drawn to scale, so it's kind of like if you put it on a number line. And a modified box is exactly the same thing, except it will indicate where the outliers are. So we're going to look at all of these today and take a look at how we can represent our data in reference to transactions of cars. All right, so we have these quartiles. We're going to find the quartiles in the interquartile range for tire pressures at cars at an auto clinic. Now, the first thing you're always going to want to do is put your data in order. Okay, so if we look at our data here, we want to make sure it's smallest to largest, and it definitely looks like it is. Okay, so the next thing we're going to want to do, if we're going to do this by hand, is that we're going to want to find the median. That's going to be the easiest way I can tell you to do it. Now remember, the median, or Q2, right? It's the second quartile. Okay, is where 50% of the data is going to lie. It's the middle number. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so our middle number would be half, would be 31. So there's our middle number. Okay, so he's the guy that divides that 50% of the data is below him. So this is going to contain 50%, and up here is going to contain 50%. Okay, so it divides our data in half by percentage. All right, so let's find our lower quartile. Okay, or referred to as Q1. Now remember, that means that 25% of the data is below this number. And when I say quartiles, basically we're divvying up our data into 4 sections using 3 numbers. So we're kind of like slicing it up into quarters. Now, the easiest way I can tell you to do that is we already found our middle number. And basically, the lower quartile is the middle number of the lower half. So here's our lower half, right here. All right? And we want to find the middle of those 4 numbers. Now, since it's an even number, if you remember from median, we want to take, and we're going to have to find the middle, or the average of the middle 2 numbers. So we're going to have to take 17 and 21, get 38, and then we're going to have to divide that in half, and I believe that is 19. So our lower quartile is 19. Let's just put it right here, which means 25% of the data is below him. All right, now it doesn't have to be a member of your data set. Let's try upper quartile, or Q3. Okay, so we're going to have to do the same thing. Okay, here is the top 50%, and we're going to have to find the middle of the middle. So it looks like 32 right here. Okay, so 32. All right, now what does that mean? That means from 32 all the way down to end contains 75% of your data. All right, now the last thing we're going to find is our interquartile range. Or referred to as Q3 minus Q1. Okay, so we're going to subtract those 2 numbers. So 32 minus 19, okay, is 13. And that's going to be your IQR. That's going to contain 50% of your data. All right. Let's try this one. We're going to find out if there are any outliers. Now, when we look at this data, we kind of went, well, 545, he's an outlier. He's way far away from everybody else. Just because he looks like one doesn't necessarily mean he is one. We need math to prove that. Okay, so we're going to need 3 things. Okay, you're going to need the IQR. Okay, which means we need Q3 and Q1. Okay, so again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. They are in order, so we're going to need to find that middle number. Here it is. That's our median. We need the lower half. Okay, so that's this guy right here. So Q1 would be 109 plus 88, and then we're going to have to divide that answer by 2. So that's going to give me 98.5. We need to do Q3. So that's going to be right here. So 202 plus 218 divided in half. That's 210. So we need to take 210 minus 98.5, and that's going to give me 111.5 as my IQR. Okay, now there's a process for finding outliers, and it has to do with those numbers, the IQR, Q1, Q3. Okay, so what we're going to need to do once we found the IQR, all right, is we're going to have to use the rule. So we're going to have to go, we're going to find 1.5 times the IQR. Okay, so these are the rules. So we're going to take 111.5 times 1.5. Okay, don't ask me where it came from. It's just, this is the rule. This is what they agreed upon back when they started doing this. Okay, so I got 167.25. So the idea is that it's 1.5 times the length of the IQR. All right, so what you're going to do now is we're going to find the upper and lower. In other words, is there a number that's above Q3? Or is there a number below Q1? So remember, this is Q3, this is Q1. That's 1.5 IQRs away from that. Okay, so we're going to take this 1.5 and we're going to do Q1 minus 1.5 IQRs. Okay, so Q1 was 98.5 minus 167.25. And we're going to get negative 68.75. All right, so now you're going to say, okay, is there anybody below him? Well, our lowest number is 45, so no. So there's no lower IQRs or outliers. So then you're going to do the same thing, except you're going to add to Q3 because we want to go above. Okay, is there anybody above that? So we're going to take 210 plus 167.25. And we're going to get 37.7.25. And the answer is yes. Okay, because this guy right here, 545, is an outlier. So we proved it. You can't just say, hey, he looks like it. You got to prove him. Okay? All right. Okay, so here we have Rod. He's doing an internet research for gallons, price change per gallon in gas stations in his county. He found the following graph. This is called a stem leaf plot. All right, so if you look at this, okay, I think we've seen these before, where this is called the stem, this is the leaf. Okay, the leaf contains normally the ones digit, and the stem is going to contain the tens digit. And if you look down here, here is your key. You have to have a key so everybody understands what it means. So this is telling us that 5/2 is 52. Now, if I didn't have that, I wouldn't know that 5/2 may have meant 5.2. Or 5/2 was 0.52. I don't know. Or it could be 5/2 is 520. We won't know unless we have a key. So you need to have that key there to understand what this data represents. All right, so what is the mean median of this distribution? Okay, so if you remember, median means we're going to add up all the numbers. Median is in the middle. Now, there is an app on our calculator, on our iPad that you can get called Graph and Calc. And it does, it's very similar to the calculator that we had when we were in the building. It looks just like it, which means that we can put data in and find the mean, median, and it actually does give you your Q1, Q3, and not your IQR, but it does give you your Q1 and Q3. So I'm going to press the stat button, and we're going to edit, just like we did when we were in the building. Now, we're going to enter the data. Now, if you remember that the stem leaf plot, okay, here he is, means 5/2 is 52. So when I come here, this 1/1, that means 11. And the next one's 11. And then it's 12. And then it's 13, 17, and 19. Okay, so these are all the line contains all of the data that is in the tens. Okay, so let's enter that. So I'm going to enter 11. Okay, then I'm going to go to the next line. Pressing enter after each one. Okay, so there's 30 pieces of data. That last line is going to be 30. All right, so we're going to press our stat button again. All right, and we're going to press the calc button across the top. You see edit calc and test. We're going to press calc. And again, you see one var stats. So we're going to press in there, and we're just doing list one. So if you remember, that's going to be second one. Close our parentheses, press enter, and it's going to give you all that information that we're looking for. Right, so right here on the right hand side, oh look, min Q1, median Q3, and max. There is your measures of, there's your quartiles and your median, so you don't have to take care of that. And over here, 39.6, and our median is 39. And that's our mean. And our median is 39, I believe we said. Okay. All right. So as Rod works through his data, he also finds a box plot. Now, remember, a box plot, I always like to think of a box plot, even though we defined it in the beginning, as a visual representation of quartiles. So if we look in a box plot, this first number is your min. This last number is your max. So you have your starting and ending numbers. The first line, okay, the first part of your box, that first line is your Q1. The ending one is Q3. And then the middle is your median. So some statisticians refer to this as the 5-number summary. So if I wanted to find the interquartile range, the IQR, we're going to do Q3 minus Q1, or 55 minus 23. And we're going to get 32. So the length of the box is 32. Remember, that contains 50% of the data. Is in this box. There's your box. Okay, last one. Okay, the following box gives the purchase price of cars of 114 seniors at West High School. Are there any cars that are outliers? Well, I'm kind of thinking 43%. I'm not sure though, so we need to do the, let's do the proof, okay? So let's do our data again, all right? And then we're gonna readjust our box. Okay, so remember, this is gonna be Q1, this is Q3, okay? So we need our IQR, so that's gonna be 9,100 minus 5,200. Which is 3,900, sorry. Okay, so then we're going to do 1.5 times the IQR. Okay, I get 5,850. Okay, now we're going to take it and go Q1 minus 1.5 IQRs. So Q1 is 52 minus 5850. Okay, we're going to get negative 650. Okay, so there's no lower. Okay, then we're going to do the other one. So we're going to do 1.5 IQR, and we're going to add, that's going to get added to Q3. So that's going to be 9,100 plus 5,850, and we're going to get 14,950. Okay, so there's our proof that 43,000 is an outlier, because we always want to have proof. Okay, now What we could do, all right, is look at the data and redraw this particular, or redraw them so that we have a dot or star as an outlier. That's your modified box. Okay, so anything that's not connected is going to be an outlier when you demonstrate this. All right, guys, if you have any questions, please let me know. Remember, staying in means we're staying safe, and I'll talk to you again soon.